functional attainment. And then it says by comparing the residual sum of squares. Is it enough just to simply say the RSS in 5.6 is smaller? Therefore, they were able to explain more, or there's not as much that this particular model was not able to explain, and that's sufficient enough to say that this particular model in 5.66 has more explanatory power. I was just
Uh,
wondering if that is a sufficient answer, or you guys were looking for something else.
I think that's not what the question asks. So basically, this question just asks the two models in 5.1 and 5.6, whether you can treat them as the same model. That means you are doing a F-test here. And F-test, so you treat one as a restricted model, another one as unrestricted, and you calculate the F statistic using the RSS from those two models. That's what we want.
Oh, why does it say that you need to compare the residual sum of squares then? F-test.
So you're confusing about the comparing, right?
Well, here, hold up. I mean, the question.
Yeah, the question asks you comparing, but you have different ways to compare. You just compare the RSS directly, and you can also do some.
You can't do that. You can't do that. Well, because it asks, it literally just says,
I know
do
literally.
this. Yeah, by comparing the residual sum of squares. If we're just going to do an F-test, then why does it say
to
in the
mention?
question?
Yeah, it's like so both of you are correct. It's not like literally like compare. There is another way to do F-test is using the RSS restricted minus RSS unrestricted over J, or by divided by the RSS unrestricted over N minus K. This is like comparison between two RSSs by using F-test in that like the way I just said.
Okay.
Yeah.
So, okay, hold. Yeah. So this question right here, whether the listening for has significant, is the same question as right here?
Yeah.
So in other words, you said that there's two methods to answer this question, right? So is this asking to do it in one particular way, and this is asking it to solve it in the other way?
Yeah, almost. But this is like comparing like 5.1 and 5.6. So
I see.
Yeah, it's a different way, but also comparing two different things. So you can get like RSS. Yeah, so you have already found out the RSS for 5.1 and 5.6. You just need to like put that into the F-test formula. Yeah.
Okay.
Yeah.
Those are two methods you can deal with the chart test and the F-test, but you have to be clear which question you are answering, you are asked to answer. So here, as you can see in 5.11, they want to evaluate whether the ethnicity dummies have significant explanatory power. So this is basically the F-test here. So you can use the same method to solve different problems. But here, you have to compare the two models from 5.1, 5.6 here, using the RSS you've gotten.
I see. Okay. Oh, and then can I just ask, like, is it sufficient enough to just say that the difference between testing whether this is just the difference between maybe like an F test and then a chow test. Like, I guess because this is asking whether they're the same, right? This is asking pretty much this test right here is asking whether they're jointly significant, and then this one is pretty much asking whether you need separate models to distinguish them. Is that pretty much the difference between the two types of tests?
I think for question 5.11, that means whether you can use the single same equation to represent those two. So this is a F test.
Yeah. Oh, this one? What's that? It's asking what the difference is.
So you're doing a test.
It says explain the difference between testing whether
Yeah, I
two
think you're
ethnicities.
right.
Yeah, so
Yes.
so pretty much the answer would be this is testing whether they're jointly significant. And this one is asking whether you need to separate regressions or if you can explain both within the same model, right? Or same.
Yes, you're right. Yes.
Okay. Okay, cool. Thank you.
You're welcome. Hi. Mm-hmm. Okay, let me have a look at question 4. Okay. So this question basically asks whether male and female, they have different schoolings. So this means that there be significant difference between those two groups. So you can try. I think this question is related to the former one, right? I think related to the question 5.1. And here is just to demonstrate that. I think if you write down the equation by yourself, it will be helpful to help you understand this question. But if you want to use R to write some code to show this, I think you can just you can by summarize in R summarize whether the two separate group mean are equal to each other. This is pretty straightforward. I mean, if you put, those beta 1 hat and beta 2 hat means that you substitute them into the above equation. You will see what this equation tells you. I mean, some terms will be cancelled. So that's why Professor Schaffen wants you to show that we can fit it with a single model and try to see whether there are significant difference between those two groups, female and males. I mean, this is a model only with the intercept, without the the x, without the explanatory variables here. So this is a simple model only with the intercept term. I think this question that we just want to understand what is this slope dummy variable means here. I mean, when male equals to 1, you will get S equal to beta 1 plus beta 2, right? And when male equal to 0, you will get a beta 1. Beta 1, which means is just the mean of female, right? So that's why it's kind of like hint that beta 1 equals to the mean of female. That's why. Yeah. You're welcome. I hope my explanation is helpful. I think this question just asks you why, if you fit this model, and you will get the beta 1 hat equals to the mean of female of schooling, why beta 2 hat equals to the mean of schooling for male minus the mean of schooling of female. You can regress the male, the dummy variable male on S, and get a result, and compare the mean of female and the mean of male. You can see what happened. Yeah, you're welcome.
Yeah. In the session earlier, is that like coded for?
Yes. No, you should. That means you have to. So you have two models. One is restricted and another is unrestricted. So ANOVA here you have to compare those two models you already have. Yes. Mm-hmm.
I have a question about 5.18. For number 7 is the
What do you mean if it together or not? Do you mean that we can use one model to represent those two groups, or use two models to represent female and male? You have to, if you want to know whether we can use one model to represent them, you have to treat them as two different models and use the F-test. We need standard both male. What do you mean the standard both male, both model? In class, Professor Xiao showed us that you can treat these as two separate data set. One data set only includes female, and another one only includes male. So that's why in data OR, if you remember, he used the sort command to separate those two groups. One model only includes a female, another only includes male. So here you can run two different models, one using the male and another using female, and you compare and you calculate. Once you use R or stata, you run two different models and you will get two different RSS, and you use the RSS to calculate the F-test, to calculate F statistics, and depend on whether we reject or not.
Yeah, but in the May 5th lecture, he had like the one model he compared them both to, which is like the LM of price in square feet, which I like considered all, which is like the standard model that I'm talking about. But there's like so many variables for this, I can't figure out what the standard one, like what the basic model is.
Oh, you mean the restricted one? The restricted one is that. Yeah, I got you. The straight one is the one you treat them the same, so you don't need to separate them. That means the data set includes both female and male.
Exactly.
Yeah, you are right. Yes.
So I'm still adding in the extra, like for this situation, I would still be adding in like the ASVABC, F Black, F Hispanic, SM, and SF. And that would just be the standard model. And then I add the male for one, and then the next one I add the female.
Yes, you're right. Yes.
Okay, I wasn't sure if I had to use all of the added variables for like the regression.
Yes, you're right. So that's why the degrees of freedom is 2n minus k. If you remember, that's why we have two different degrees of freedom. The unrestricted model, the RSS, is the sum of those two separate ones.
Okay, yeah. Got it. Thank you.
Yes, you're welcome.
These questions in number 7 is just doing a bunch of chow tests. Am I mistaken? Because I feel like I'm hearing the same things. Whenever they say, does sex affect educational attainment? Ethnicity, does that affect educational attainment? Evaluate whether the dumbbells have significant explanatory power. Are they all just a bunch of chow tests?
Yeah, you're correct.
Okay, and so pretty much if by doing it this way, this would be doing it, this is the two model way where you're comparing this p-value and this p-value. Is that correct?
If you are doing like two model cases, you can just compare this one.
Oh, you're just looking at this right here.
Yeah.
I see. So pretty much, so for all these questions here, right, I can create the unrestricted model, then the restricted model, right, with these, and then do the ANOVA for model 1 and model 2,
Mhm.
and then look at this p-value. If it is under 0.05, then you can say that, you know, that male and female, then ethnicity affects it, or like, gender affects it. But if it's over 0.05, then you can, this model right here, unrestricted, would be sufficient. Am I correct in saying that?
Yeah, but I will just like rephrase a little bit because
Oh, okay.
value bigger than 0.05, we can never say like we can never say like this is correct. We just need to say this. We cannot reject the null hypothesis.
Yeah. Okay. Yeah. We cannot reject null.
Yeah.
Got it. Okay.
Totally correct.
And you should be careful about the restricted model.
Okay.
I mean, when you say you have a restricted model, you have to be careful what null hypothesis you are testing. That means.
Oh, we're talking about this, right? When we're, you mean like the ANOVA?
Yes, we say restrictions. We mean that the null hypothesis, like you have a beta 1 equals to beta 3 equal to beta 4 equals to 0. This is basically the joint hypothesis. So if you say restriction, if you compare two models, you should know which variables you are comparing with, and be sure the ANOVA will give you the result you want.
I see.
Yes. So
This particular model is comparing male and female, and this is the slope. Is this the slope dummy? And then this one is the intercept dummy? Am I tripping? So this is just comparing the two variables, male and female, right?
Yes.
Okay. And then in this particular one, like, let's just say 5.
Please wait a minute. Okay, can you see my screen?
Yeah, I can.
So, do you guys hear echoes?
Yeah, it's a little echoey.
Okay, I'm sorry about that. Okay, here, as you see, so this is the first model we care about. This is just random variables. We call it X. If we want to see like for male and female, so if we just run this model, it's just Professor Xiaofang said support model. That means we treat those two are the same. We don't want to separate them. We want to use only one model to represent those two groups.
Okay. Yeah.
Yes, but if you want to, you say like I don't think we should use this single model to represent these two, and you might want to say xi equal to beta 1 equals beta 2 xi, and you use a data set only includes female. They are the same model, and you can also like run a separate one, and this data set only includes male. And you compare those two. So that's the question. I think someone just asked before that whether the standard one. So this is our restricted model, right? Those two, and we call this model 1 and model 2, and that's why the RSS unrestricted equals to the RSS 1 plus RSS 2, right? This is how you do the child test. And why? So the dummy variables, how dummy variable works here? You don't need to separate them. You can write it as you want to check, like you can have a male here. So when male equals to 1, this model represents male's model. And when they equals to 0, this will be female. So that's why we need dummy variables. It's pretty convenient for us.
I see. And then, okay. How are you able to, I'm just a little confused about how you can check to see whether male is 0 and male is 1. Like, where do you look? Or is that something you input? Is that something you code? You just set male equal to 0? Or do you check to see if male equals to 0?
You can check your data set. It's already set before. So your data set will have a variable named male. You have the like 111 and 01100, and you can. This means this observation 1, observation 2, 3 to n, right? And you won't have a variable named female because when male equals to 1, this variable is a boy, and this is also a boy, and this is a girl. So that's how we differentiate them. And if you have a variable called a female, you will see this will be 0 for female variable. This will also be 0, 0, 0, and this will be 1, which means this observation is a female, and this will be 0, 0, and 1, 1.
Okay.
You can check. Yeah, you can check your data set.
Okay. Can I share my screen again real quick? I really want to clarify something.
Okay, sure.
I just want to clarify it. Oh.
Oh, I should quit sharing. Sorry.
Oh, it's okay. It's okay. So
Now you can share your screen.
yeah, so for instance, let's see. Okay, yeah, Shin Yi just said you can call up male equals 0 and male equals female. And so like I'm trying to see where that comes into play, or like where you can see or like
Okay, hold on here. You see the coefficient for male is 2.11, right?
yeah.
This only happens when male equals to 1. When male equal to 0, you will not have this coefficient.
It'll just be 0, or it'll just be like NA.
It will not happen here. That means your model, how to say this? So you see here, you can interpret this coefficient as the intercept.
This one,
And
2.11.
Yes, and you can see the intercept 11.13. That one, it means when this actually is for female.
Wait, where's 11.13?
No, your result, your result here, the intercept, the first one, yes.
Oh, 17.13.
Yeah.
And that's the intercept for
Female.
for female.
Yes.
And then for male, is it 17.13 plus 2.1158?
No, that's a difference between those two groups.
I'm sorry. I think like Jacob is correct. So for male, it's just 17.13 plus 2.11, and 2.11, as he said, is the difference between male and female for the intercept.
Yeah, that's what I was.
And I also want to mention the things I said, like in the chat for male equals 1 and equals 0. That thing is when you like for the JP's question, like in Dorothy's 5.4, you want like that is a case you use male equals 1, like for the you said like maybe like in the example like as and bracket male equals 1, that represent like the male's schooling, and as a bracket male equals 0, that is like women's years of schooling.
Oh.
Yeah. And also go back to like Daniela's question, and when you like for doing like 5.27, I think, like when you use like the sort, like for the RSS equals RSS1 plus RSS2, you're doing like the subset. And that is also the case you are using like male equals 1 and male equals 0. And also like for the quiz 6, you are doing the same things, like just for different variable. Yeah.
Okay.
Want to add.
Okay, cool. And then, okay, yeah. So in this particular question, let's just say, in this question right here, like this one right here, there's no slope dummy in this one, right? It's just an intercept dummy.
Yes.
Yes.
Okay. And you can say that sex does affect an individual's educational attainment without a slope dummy. You can just do that with an intercept dummy. Like you can claim that it does or does not affect educational attainment without actually having a slope dummy as well.
Yeah, sure. The slope dummy means when you have slope dummy, like when you add the tenure times male, that will examine the effect of tenure on the gender. So you have intercepts that only that's the question asked, that whether the female have some effect on the schooling. That means have the gender effect on the dependent variable schooling. So you won't need a slope dummy here.
You won't need a slope dummy here.
You won't need a slope dummy here.
Yeah, okay. Okay, cool. All right, perfect. Thank you. I appreciate it.
You're welcome.